So let's get started. Hi and welcome everyone to the course of Advanced Digital Communication Systems, subtitled as Software Defined Radios and Open RAN. In the last lecture, I shared with you a link from which you can access to the main video lectures that are covering the topics that we want to talk about it during this course. Up until now, we have talked about the motivation behind open source based hardware and software for building 5G and LTE 4G networks. We gave you two videos about the introduction to this type of networks. We addressed the why we need this and how you can build such a network in simple terms, and then we talked about the 4G, 5G full stack covering the E node B, G node B, user equipment, APC, and 5G core. We talked about also how to set up the SDR devices, USRBs, with an open source 4G, 5G suite tool, and we talked about 4G network setup. I actually collected few videos for you and shared all these videos with the students who requested a clear understanding of how to build 4G network from scratch. And we talked about Dragon OS. Some of you sent me summaries of what they understood from these videos. Some of you, they didn't send me yet. But like those videos, in a nutshell, they explain to you a new operating system called Dragon OS that basically combines all the different SDR tools and teaches you how to build an LTE network or 5G network using open source software. Now, as you know, in the lab we have a USRB of type NI 2920. Yes, 2920. And this USRB, you can convert it to a USRB of type 210N, N210. And this USRB is compatible with UHD, and we spent significant amount of time trying to connect the USRB, which is the software-defined radio, with the open source software we have called SRS-RAN. And after, due to the claims of the company SRS-RAN saying that this software is capable of working with any hardware, any reconfigurable hardware, software-defined radio, and assuming this to be true, we just started working on integrating USRB N210 with the software. After working for about 1 week or two, we found out that there is a very critical issue that we found in this type of USRBs, N210, and this issue is related to the clock rate. The clock rate of such USRB is found to be equal to 100 megahertz, and this clock rate is not compatible with the clock rate that's being used inside the SRS-RAN software. And due to these incompatibility issues, we were stuck and not able to move forward with the system, with the prototype that we wanted to build inside the lab. And due to this reason, we thought since we found it very clear that there is no way we can open a 5G or we can build 4G or 5G network without making the hardware compatible with the software, we advised you to buy some open source hardware devices like SDR, LIM SDR Mini, and Black Hack, Blade RF, and what else? We have the Ethos X310. All these three devices, software-defined radio devices, are tested, and they were tested by different communities around the world, and they are compatible with the SRS-RAN. So they have no issues working with the SRS software RAN. but the issue appears only when you use N210 USRP with the SRS-RAN software. Now, there are researchers who try to do what we exactly wanted to do, using N210 with the SRS-RAN, but unfortunately, they face the same problem, and they suggested that they can manipulate the clocking rate inside the software in such a way that they make it compatible with each other. But unfortunately, the SRS-RAN company didn't comment on this, and they didn't provide further information to investigate how to solve this problem. And what I found later on that those USRP devices, if you use USRP with the software SRS-RAN, those are good for prototyping purposes. Like this USRP, the one I'm holding in my hand, it's good if you want to build a prototype. You have an idea, you want to demonstrate it to a company or to a funding agency to get some fund and to demonstrate that your idea can work. This USRP is good for this, but this is not good for production. USRBs, guys, this is very important information. USRBs are not very good for production. What I mean by production, you need to deploy this outside and make it serve real users on the street. This is not good because it's going to be impacted by rain. It's not rain robust, resilient. It's not waterproof. It's not like against wind and the environmental circumstances. So we dig deeper and we try to understand more about this open source 5G system and LTE and this, and we found out that you don't need to use these USRBs. Using USRBs is not the only way to build private open source 4G, 5G network. And in this lecture, we are going to be sharing with you some of these possible ways and how you can practically, after this lecture, I expect it from you guys, the ones who are serious, the ones who are really serious and want to build business out of this. This is not yet well known in the world, and not everybody can understand an article by reading it by himself or herself. Like if I ask Sadiq to read it, he will have some gaps, some leaking points, some misunderstandings. So I want to clarify all these things and show you step by step by following an article online how you can build a business out of these things, ready for deployment in a realistic environment, outdoor or indoor, that can serve users on the street or in homes or in offices or in buildings. And this was perceived as something impossible to be done in the past. But with the emergence of a new type of companies, startup companies who are really motivated, they were being motivated by governments like USA governments and others. The governments, the FCC organization, which is responsible for assigning the spectrum to companies, they opened some bands for these companies to build new products that can work as kind of work on unlicensed spectrum. So you don't need to buy a spectrum that costs you billions of dollars. You just can use it by utilizing the spectrum that the government gave for free to these companies or operators to just utilize it and use it in order to build a free 5G, 4G networks. This accelerated the process of innovation in wireless, and in this specific lecture, we will be talking step by step how to build this from scratch, like using off-the-shelf hardware devices and some tools and hacks, and learn the exact procedure, not just for prototyping inside the lab, but also outside. Prototyping and building simulation environment is good in case if you just want to demonstrate something you are doing in research, or you want to test your algorithm. but this is not good for production. Now, this is the unique thing about this lecture, where we will learn the production networks by following a recent article that we will start explaining step by step.